Well, welcome to this brief tutorial on physically based rendering. Physically based rendering, or PBR for short, is one of the two rendering engines that comes with Houdini, the other being the standard Mantra renderer. Let's get started straight away. I've got a very simple scene here, a grid and a sphere. I haven't yet added a light, so let's do that. I'm going to control click on a distant light to add it to the scene and move the view out slightly. Now, to create a PBR render, you just need to lay down a standard Mantra node. And on the Properties tab and the Rendering Type tab, you have the options here for Micropolygon rendering, which is the standard Mantra renderer, ray tracing, which is again the standard Mantra renderer but using a ray tracing algorithm. And then you have two types of physically based rendering: Micropolygon physically based rendering and standard physically based rendering. The difference between these two is that in this first option the geometry is split into micropolygons, which is exactly what the standard Mantra renderer does. And the advantage of that is that when it comes to doing motion blur, it gives much faster, more accurate results. However, it tends to be slower and produce more noisy results than physically based rendering when you don't have any motion blur in your scene. So it's generally a good idea to use physically based rendering, this option, if you don't have much motion blur, but if you have significant motion blur, to use this option. Let's choose physically based rendering for the moment. Let's see what this looks like. We can do that in our render view here, and if I choose our Mantra render and click render, well, we get a completely dark screen. And this illustrates one of the other aspects of physically based rendering, which is it does not implement all of the features of the standard renderer. One of the things it does not implement are distant lights. So let me turn that off. Go back and delete our distant light and lay down an area light instead. And area lights are one of the things that physically based rendering does particularly well, along with environment lights, although it does recognize spot and point lights. So let's set up this area light. I'm going to set it up with quite a large area. So let's increase this area size to 10, and let's render again and see what we get. Okay, well, we're getting a result this time. We're getting a nice blurred shadow and a nice big highlight here. Now, we're getting a shadow even though on my light options I've got shadows set to no shadows. So one of the other things that PBR does is automatically enable ray trace shadows. Let's pause this. So here's the finished render. As you can see, it's producing a nice effect, but there's still a lot of noise in here. The reason for that is because the PBR renderer tends to need a great deal more samples than the standard Mantra renderer. So at the moment we've got this set to 3 by 3. You probably want it up at something like 15 by 15 or even 20 by 20 to produce a smooth result. Note also that the way you control sampling varies depending on whether you're using physically based rendering or micropolygon physically based rendering. In the case of physically based rendering, which is what we're using, these controls here, the pixel sample controls, control everything. The quality of the shading, the quality of motion blur, the quality of the geometry and aliasing. If you're using micropolygon based physically based rendering, then the pixel samples only control the anti-aliasing for motion blur and for geometry. If you want to smooth out the shading itself, then you need to use the max ray samples parameter and increase this. There are some other things that the PBR engine will not do for you. It tends to ignore things like background and environment colors. So for example, if I make our shader into a glass object, which I can do like that, and then if I try and give a background color which is, say, blue, you can see it's taking no notice of that. The background is still black. Similarly, it pays no attention to attenuation. So if I was to increase the attenuation here and re-render, the result is no different than it was before. This is because of the nature of the way the PBR algorithm works, which at the moment makes it difficult to take into account these values. Another thing that PBR unfortunately doesn't currently do is use a irradiance cache. So even if I were to set up here an irradiance cache, if I render again, the result is exactly the same. But one of the things which PBR does do, which the standard mantra renderer doesn't, is give you reflections of your lights. That's what this large shaded area here is. It's a reflection, a direct reflection of the area light that we have in the scene, as is this. This can cause some problems, as we'll see later on.